Hello everybody, welcome back to Cement Manufacturing Practice Series, episode number 6 on Chemical Industries Engineers channel. After milling and separation, the next step is blending. To produce clinker with required composition, limestone and correcting materials like clay and iron ore for example should be mixed. Some mixing may happen in raw mills, but it's not enough. So we should make a separately blending operation. In wet process, it's easier than in dry process, and that give wet process more lifetime. It's done by slurry mixer, where the slurry mixed by slow stirrer in the center of the mixer, and let the compressed air bubble from the bottom through the raw meal and blend it. Limestone and correcting materials stored at separately silos and then fed to the mixer with specific proportions to be blended. Where in dry process we have a pre-blending process. In pre-blending process we can get blending degree to about 5:1 ratio. That means, for example, if the calcium carbonate instant proportions in the feed varies by plus minus 5% before pre-blending, after pre-blending the variation will be plus minus 1%, calculated as a standard deviation. But to get good quality clinker, the variations of the calcium carbonate, for example, in the feed should be plus minus 0.2%. calculated as standard deviation. So we should have another blending process. In general, a blending process for dry raw meal done in silos. The silos designed with tiles over the ground. The process starts with passing the air at low pressure through the raw meal and reducing its bulk density and making it flow like a fluids if the ground in a slope. In batch process, the silos for this kind designed to receive a raw meal as a batch in a few hours. So we need two silos, the first for blending and the second for storage. Different designs and equipments used, but in general it's the same mechanism by fluidization process. In batch process, blending ratio about 8:1 to 13:1 ratio. In some designs, batch process made of two silos. The blending done in the upper silo and the storage in the lower one. For large plants, batch process is not suitable because large kiln require raw meal stock for 2 to 2.5 working days. So it requires many silos with large size, and this would be too expensive. Where in continuous blending process, feeding, blending and extracting carried out at the same time. So we need one silo used for both blending and storage. In addition, it gives the required blending factor in sequence with the pre-blending process. Principle of continuous blending process like a blender where the feeding is distributed in horizontal layers in the silo and followed at the bottom of the silo with central cone. The feed enter to the cone by flow control gate. This flow making the feed form a shape like a funnel at the gate and mixing the feed from different layers with each other and then discharge and the air discharged with inner discharge pipe. Continuous process consume power less than the batch process because it's not necessary for the air to pass through the whole height of the raw meal. In some rare cases, the blending factor will be less than the required, so we would have two silos in continuous blending system. X-ray analyzer used to calculate the instant proportions. In batch process, the blending factor is high enough to eliminate using of X-ray analyzer, where in continuous process the blending factor is low and it's high risk to use continuous process without X-ray analyzer. We should test the raw meal proportions during blending up the piles, reclaiming from the piles, feeding to the continuous silo, and after reclaiming it from the silo. And this can be done by X-ray analyzer and autosampler, which give us the instant proportions of different components. But the problem, this testing system is expensive, and this makes this system inefficient for small plants, which use batch system instead, and it can be afforded by big plant only. And here some problems happen in the silos. The first problem, agglomerate for the raw meal during storage. The solution, clean the silo and check for the leaks. If there is no leaks, install dryer for the aeration air system. The second problem, the air supplied to the aeration system was reduced. The solution, check the air filter and check the air distribution system. The third problem, losing in the aeration air amounts. The solution, empty and clean the silo and check the whole aeration system for leaks. The fourth problem, one activated section in the silo. The solution, check the air distribution system. I hope this video is useful, and if you work as a chemical engineer in cement factory and interested to share your knowledge and experience with other engineers, please feel free to contact me at any time at my LinkedIn account. And don't forget to like, subscribe, and share the video. Thank you.